Hi, this is Ben, and this is my lesson on graphing equations and such. And the equation that I'm going to use as an example is y equals x minus the... Oops, I messed up. Oops. Hi, this is Benjamin Levine, and this is my lesson on how to graph equations and such, like domain and range. The equation I'll use is right over here. Y equals 4 minus the absolute value of 2 times x plus 6. We'll start by finding some possible inputs, and I like to use ones in order around 0, so what about -2, -1, 0, 1, and 2? So we'll substitute each of these for the variable x, which represents the input, and we'll see what we get. So if we say, well, we can start with 0 because that's easy. So we'll start with rewriting the equation. So we have y equals 4 minus the absolute value of 2, 0, plus 6. And we can simplify that. Y equals 4 plus 2 times 0 is 0. The absolute value of 0 plus 6. And we can simplify that further. Y equals 4 plus the absolute value of 0 plus 6 is 6. 4 plus 6. And then y equals, I'm sorry, that plus should be a minus. Sorry, so that's a minus. So 4 minus 6 equals -2. And so now we know that when 0 is the input, -2 is the output. So we can write that like so in an ordered pair. Parentheses, 0, comma, -2, close parentheses. And in an ordered pair, the input always goes first, which in this case is 0, and the output always goes last, which in this case is -2. So x and y, input, output, 0, and -2, in this case. So I hope you understand how to do the equations and how to find the ordered pairs, and I did some other ones just for the sake of time. I don't think we would have enough time to do all of them, and I did a few extras other than the -2, -1, 0, 1, and 2 that we talked about, so that when we actually graph them, you can see the interesting pattern that they form, which is sort of like a V, an upside down V. So let's graph it. So what we're going to do, we'll take the first ordered pair, -2 and 2. So we know that -2 is the x, which is the input, and 2 is the y, which is the output. And on our graph, we'll label this axis, this one right here, the x. The horizontal one is always the x, and this one right here, the vertical one, is always y. Okay, so we know that -2 is x. So we're going to go along here and find -2 right here. Then 2, we're going to go up, and there's 2. So at the place where they intersect, which is right here, we're going to put a little dot right there. And we're going to do that for every single one of them. So -1 and 0, we're going to find -1 along the x, which is right here, and 0 along the y, which is here. So we would place the dot right here. Okay, excuse my writing on the iPad. I'm not very experienced. Now our next one, 0, -2. So we know that the 0 on the x-axis is right here, and the -2 on the y-axis is right here. So we will place the dot right here. And I will do 1, -4 quickly. So 1, -4, and this should not be negative. I'm not sure why that's negative. Sorry, but that's 2, -6. And then here comes the interesting part. We've got -3 and 4. So we'll find -3 right here. It's here. And 4 up here. They intersect right here. Okay, so that's all as expected. Probably. Right, as you can see, they're in a fairly straight line right here. Well, it should be absolutely straight, but my drawing skills aren't perfect. And now this -5, 0. So we have our -5 right here, and our 0 right here. Oh, interesting. So now it's sort of going down, as you can see. And now we have -8 and -6. So again, we're going to go -8, -6, and we'll give it a little dot. And if you wanted to fill in all of the ones in between, it would look like this. Okay? And then to really, if you wanted to fill in everything, it would look more like this. Because the domain and range, which we will come to, your input, you can have any input you want, and you will get an output. At least if it's a real number. And you can have any output, except if it's greater than 4. We'll talk about that when we go over domain and range. And so when you're making this a continuous graph, which means that you have a line between the points, I'm going to put arrows on the ends to show that it goes on in this direction and that direction forever. And this line is basically made up of infinitely many points along the line, showing that, like, say you went in right here. That's like, what, -8.5 on the y-axis and -8 3/4 on the x-axis. That there's a point right there. You could put in -8 3/4 on the x-axis, and you would get about 8.5 on the y-axis. So now we're going to talk about the domain and range of this equation. So the domain, which is right here, and the range right here, we haven't filled them in yet, but the domain basically means the acceptable inputs. So the acceptable inputs can range from, you know, in a random equation, it can range from, say, -3 to 8, or -1 billion to +1 billion. And in this case, the domain is any real number. That's because on the x-axis, right here, this graph can go on forever. And eventually, not for a very, very long time, but you will get to infinity way over here. If you go down far enough, the graph will extend all the way to infinity. And same thing on this side. So that is the domain of this function. So let's write it down. Any real number is the domain for this function. Okay. And the range, as you may have guessed, with the domain being the acceptable inputs, the range is the acceptable outputs. So basically we're doing the same thing except along the y-axis. Now you might think that since this is a continuous graph, which is part of the reason why you can tell that the domain is any real number, you might think that since it's a continuous graph, it goes on forever, but that and so the range is any real number, but that's not actually true, because as you can see, this graph stops right at 4. The highest point on this graph is right at 4, and therefore the range is any real number less than or equal to 4. Sorry about that. Here we go. This is interesting. There we go. Looking good. The range is any real number less than or equal to 4. And again, the reason for that is this graph, if you zoomed out, it will keep going down in this direction and that direction, but it will never, ever go up. It will only go down, and it will never rise above 4. This is the highest it can go. The last thing that I want to talk about is estimating numbers directly from the graph. So you can do this with both inputs and outputs, x's and y's, and you do that by you have to know one of them first. So say your input you knew was 7.5, which is right here, right? So what you would do, you've already graphed it, your lines are here, and you would just follow that 7.5 down until you hit a line. Boom, I hit a line right here, and it looks like it's about -5. Now it's not going to be accurate, completely accurate, all of the time, but it's going to be close enough to give you an idea. So we know that that point right there is pretty close. This point, which corresponds to -7.5, x, as an input, would probably have around -5 as an output. And you can check that in a calculator or a graphing application if you like. Now you can do the same thing with outputs on your y-axis right here. So say you knew that your output was, let's say, -9. Now this is a little bit tricky since I didn't actually draw my graph down here. So, but you know, it's pretty easy. All I have to do is extend the line. Right? I know it looks something like that. So I'm just going to extend my line. And now we can follow our -9 over until it hits the line. Okay, so it looks like it's about -9.5, corresponds to -9. But there's also something else. If we followed -9 this way as an output, it also takes us to around 4. So it looks like both of these inputs, something around 4, and -9.5, both give us -9. So that is how you estimate either the input or the output from its corresponding output or input. Thanks for watching.